So let's get slowly started. I see some people are still joining, and while that's happening, I can do a bit of intro on this webinar. As you can see, also, I'm trying out a new thing here in Zoom because I know some of you have already been to our previous webinars. So now they have some possibility that when you're sharing your screen, you can be overlaid on the screen. I hope it works out well. You can see I'm now next to myself here. Somebody mentioned in the chat that I should be wearing the same outfit as in the picture. Well, that's maybe for the next time. But anyways, let's get started. So at the beginning, as always, just some general info for the webinar. So I expect the approximate duration will be around 1 hour, including the Q&A session, but let's see how it goes. Please, one thing is make sure if you have any questions, please just put them in the Q&A section rather than the chat, because we have a few people also monitoring the Q&A section. So some of your answers can get already answered quicker. I'll also be monitoring that. And then either during the webinar, I'll try to answer those questions, or at the very end, we'll have a Q&A session. And then I will be trying to go through as many questions as I can. And yeah, so in case you cannot stay until the very end, the webinar is also being recorded, and to everybody registered, the recording will be sent afterwards, and it will also be published on our YouTube channel. So yeah, all questions in the Q&A, and let's get started. In general, today, I want to talk with you about the new feature, which we added recently in UgCS flight planning software in UgCS 5.5, where we added the Circlegrammetry tool. So I'll explain a bit about also the background on this tool, sort of how we came to put it there. I'll show you the demo of how it exactly works within UgCS, show you a bit of data examples as well, and then I think we're going to go into the Q&A session. So, all right, then I think let's proceed. I'll just quickly switch my screen share into UgCS so you guys can see that screen, and let's try. Okay, so hope you should, yeah, I think you should be able to see it. All right, so I know some of you are already experienced with UgCS. Some of you are probably new to it. So I'll just explain in general how a basic photogrammetry mission is planned. I'll try to go over that somewhat quickly. Then how would you change that mission to scan instead of doing just normal mapping to do oblique capture? And then we're going to go into the Circlegrammetry tool itself. Sounds good? Okay, then let's get into it. So here you can see already on the screen, I have our demo mission. So this is what you would see the very first time you open up UgCS. By the way, now you can also switch between light and dark themes for sunlight. That's just kind of a quick side note. So let's go to some area where we can maybe plan our new route for just a simple photogrammetry mission. I'm right now here somewhere in the Swiss Alps. That's the default location of UgCS. So let's go ahead and first create a completely new mission. And then let's create a new route. Something very simple. Let's maybe make it for the Mavic 3 Enterprise drone. Yeah. Okay, so now let's go here into the photogrammetry tool. So for the photogrammetry, you can see we first have the camera field. So we're typically choosing the camera that we're using. In this case, this will be the wide camera, and we're choosing some ground resolution parameter. And then after that, we can simply mark out the area that we want to scan. Complete it. We can also adjust the direction angle of this. And then we can see we have some very, very basic, very small photogrammetry mission already planned in here. Then if we go on further into the actions, so we can also see what actions UgCS adds in here by default. So for standard photogrammetry mission, we have the set camera attitude to 90 degrees, and also we have the set camera by distance. Also here, by the way, I'll change the turn type to adaptive bank turn. And yeah, so this is obviously very standard, very normal mission. I'm sure you guys have seen quite a lot. And so this is kind of what you would use for normal mapping. Maybe the overlaps would be slightly different. So you might be using something like 80 and 70% overlap, which I think is quite commonplace. And if we go now up here into the elevation profile, so you can also see the total estimated distance. You can see the total estimated duration of this flight, et cetera, et cetera. So all of these things. So this is basically for doing a normal mapping mission. Now, for doing something like an oblique capture, you don't want the camera obviously to be just at 90 degrees. You probably want the camera to be at some oblique angle, whether it's 45, 60, 70. It depends really on what you're scanning and what type of data you want to get. So for the standard photogrammetry mission, what you can do here is you can go into advanced settings, and then here is the double grid checkbox. And then after you check that, then you'll see that UgCS makes this into a double grid mission. So essentially 2 grids overlaid over one another in perpendicular. And then here we can go into actions and then change the camera tilt to, for example, something like, let's say, 60 degrees. And so now this means that the drone will fly through both of these, both of these grids, which are overlaid in the same segment. And it will be taking pictures using this action, and then the camera will be pointed at 60 degrees. But one problem with this is, of course, this is quite time consuming. There are also, of course, alternatives. So also we've tested quite a bit of the oblique scan that's in DJI Pilot 2. Also, great tool, but there's also some downsides to that. So for example, if you're using this tool found in GCS, so it's standard photogrammetry, you can see that this tool actually, it doesn't really go outside of the boundaries which you have planned here. Of course, here in this specific case, you can see it's wide open landscape, but in real world scenarios, very often you have some obstacles. These could be buildings, these could be trees, towers, and so on. The problem with Pilot 2 oblique mission is the fact that you can select some area, and Pilot oblique, I mean, in the case of, let's say, Mavic 3 Enterprise in this example. So you mark out some area for the oblique mission, and then Pilot 2 will actually make, again, multiple grids. So basically 2 grids overlaid on one another, but so these grids will go outside of this boundary that's here. So the big problem is that, and we will see it later on also in the data examples, is that it makes the drone fly way outside that area. And in some cases, that's okay. But in some other cases, that can cause a problem because you might not be able to fly outside of that. And that's exactly what we encountered when we were in the field, because we wanted to fly lower to capture, well, basically higher resolution data, but we were not able to fly outside of it because there were trees all around. So we were scanning an old military base, which is now converted into a laser tag polygon. And you'll see that also there further in the data. So that's one issue. And then if we overall look at these sort of, standard grids, one problem is that the camera angles on them, so they're somewhat fixed in the sense, you're only flying in these straight lines. And sometimes this doesn't fully capture the complex geometry, which could be there on the ground. So this means you're missing out on some details. And this is kind of where we came up with this idea of, we already had the tool for planning just, orbits inside of UgCS. Maybe I'll just quickly show to you. So we had just what's called the Circle tool here. This has been in GCS for, I think, already 10 years, probably. And so, yeah, then we had the thought, what if we used basically a combination of these to do a scan, to do an oblique scan? And that's kind of where the idea of Circlegrammetry came around. And yeah, so now let's maybe go into that, and I'll just show you how you can plan a Circlegrammetry mission, at least a very basic one that we're going to plan over here. And then I'll show you some more real world examples before we go into the data set itself. Actually, maybe one thing I'd like to do, let's maybe go to some other location here on the map where maybe it could be a bit more interesting. Maybe let's go somewhere over here. We've seen there's a lot of cool areas around San Diego. So let's see, let's maybe zoom in somewhere in here. A bit more green, a bit more pretty as well, at least to me. So, and also much more practical because you can see, of course, there's buildings and a lot of more interesting stuff happening here on the ground. So let's maybe try to plan a mission here. So now you can see we have a new route here created, and now let's already go into the Circlegrammetry tool. So the parameters here that you need to set are somewhat similar to what we were setting before. So first, you have to choose what camera you're using. In my case, I'll be using the DJI Mavic 3 Enterprise Wide camera. Next, you have to set the flight height. Then just to start off with, I'll set this to 50 meters. And by the way, to those of you from the US who use the Imperial system, in the main menu of UgCS, you can change this into feet if that's what you prefer planning with. And then next for the radius, also for now, I'll just set it to some basic value like 30 meters, for example. And now let's already mark out the area that we want to survey. So let's just initially maybe select this area over here. Direction angle already has to be adjusted. Let's maybe put it like so. Okay, and just to make things maybe a bit more simple, I'll just decrease the overlap just so it's more basic, at least so we can initially look at it and what the software offers for us here. So then what do we see? So essentially, once you have this area marked out, then UgCS puts a series of circles all through the area. And the way we've designed this algorithm is so that from whichever point the drone starts flying, and you can see in this case, it's this point over here, the drone will essentially fly through here without stopping. So it will just start doing these loops, and it will look towards the center of each of the circles as it flies around them, and it will keep taking images here. And only I think here it might kind of briefly pause, move on to the next line, and again fly without stopping. That's kind of how the algorithm here is designed. And one thing you can do here, what's really interesting, is that you can control a lot the amount of data that you want to gather in these missions. That's one. And the next thing is that flying like this actually allows you to capture data from a lot more different angles. So for example, if you have on the ground, multiple buildings, or maybe even this could be some, industrial plant where there's maybe some pipes going through, things like that, then you can capture more data, you can capture more geometry here, and you can adjust actually, so how much data you want to gather in these places. One interesting example is I tried to find where was it in my data archive. Couldn't find for this webinar, but I also flew during the testing phase of this. I flew around our office, and I also kind of compared the Pilot 2 results with Circlegrammetry. What was interesting is that some small geometry that's on the ground, like an electrical box, for example, with Pilot 2, even though it had 2 times more images in that data set, Agisoft could not manage to correctly reproduce that. While from Circlegrammetry, even though in that case, Pilot 2 had something like 470 images, I believe, and Circlegrammetry had only about 200 something, it managed to produce that geometry more accurately. So yeah, that's just one example where it does work better. And then you'll see a bit more later on when I show the data itself as well. So in any case, let's just go through the parameters and how it works. So number one, you have the flight height. And then, of course, you have things like the flight speed. The flight speed here by default is set to 5 meters, but actually I would suggest flying, at least with this specific drone model, a bit faster. So maybe something like 8 meters per second, or you could try even doing 10 meters per second. But keep in mind, main limitation there is the camera itself, because of course the camera has a certain triggering interval. So it depends how quickly can that camera shoot. But I think 8 meters per second would be maybe a good start for us. Next is the radius. So in this case, the radius I can keep as 30 meters, maybe even 25. So we could, for example, do something like this. We can also open up the elevation profile. And so now you can see this whole flight. So actually this whole flight, these circles, this would take about 8 minutes in total. And another thing which you can do is actually you can adjust the shots per circle. And now if you want to see how many shots will the drone take, you can just go here in the route settings, and well, not settings, but essentially the calculated route parameters. And so here you can see the total area size. You can see number of circles as well as the shots per circle. So you can see that currently UgCS has calculated that there's 18 shots per each circle, and the total amount of shots should be around 378 shots. But this we can actually adjust. So for instance, if you maybe want to save some space in the data, if you want to capture less, then of course you can adjust the shots per circle. So for instance, you can tell, okay, I only want to capture 10 shots per circle. And then you can see already here in the root parameters, you can see that this parameter has been changed. But if you want to maybe revert back to the automatic, then you can just remove that and you are back at automatic. One thing you'll notice in this flight planning tool is that here under actions, you can't actually change any of the actions. So these are set for the tool automatically. So it will automatically trigger the camera at each of the points. And the camera angle, if you're wondering about that, this is set through here. So you can see that by default here, it's currently set to 45 degrees, but you can, of course, change that. And from my experience, I managed to get even better results if I was flying at 70 degrees. It will depend, of course, on what object you're scanning, what altitude, and so on. But so this, for example, you can change to 70 degrees here. And then one of the next things is that you can also, of course, change the overlap of the circles. So currently it's set to 20% overlap. And for example, if it's set to 50% overlap, this means that each of the circle, sort of the next circle starts and goes through the middle of the previous circle. So why we didn't put some exact image overlap here? Firstly, because it can be a bit, initially harder to exactly understand because there's a lot of parameters like, radius, altitude, the camera angle, and so on. And we wanted to see what you guys do with this tool, how you use this, because this is something a bit new to the drone industry. And we really want to gather some feedback from you, seeing what do you think about this tool and how you use it and what kind of data are you gathering with it. So we're essentially giving you the tool so that you can use it and then let us know what you think about that. That's what I'm really curious about. That's why I wanted to bring this faster out there and see what comes of it. So in any case, you can see then we can set the circle overlap. And also from Mike's, when I was asking different drone pilots, some said when they have used similar flight planning tools in the past, then some of them said, yeah, 50% is the best overlap to use for these circles. Some said no, like, that's a bit too much. They prefer 30%. So I think it will be quite individual. So for now, we made it really simple. If you set the circle overlap to 50, circles overlap by exactly 50%. If you set this to, for example, 0, then the circles will just touch, but they will not overlap at all. So you can experiment a lot with this as well, but I'd say some maybe good value would be starting from 50 until 30%. That would kind of be my recommendation to get started with this. One cool thing also, by the way, is that this tool does do terrain following. So in case you want to maybe scan some area that is located on a mountainous or hilly surface where the terrain is changing, then you can have terrain following in here. By the way, I quickly mentioned just two new things which we have added recently into UgCS, in case maybe you have not yet noticed that. So number one is that now when you are actually scrolling through any planned route in UgCS, you can see that there's this tiny red marker that's quickly moving through the route. So actually now you can really easily understand at what point in the route are you. And you can see, for instance, if maybe the elevation gets a bit too close to some planned route, not specifically Circlegrammetry, could be standard area scanner for the Grammetry mission, then you can see exactly what part of the route you have to make some changes to. That's number one. And number two is that when we added the Circlegrammetry tool, one thing we realized is that there's a lot of waypoints that can get added there, and it just makes it a bit more visually complex to understand these missions, especially if you do it if you fly them with high overlap. But so now what we did is we added the possibility to trigger additional waypoint visibility on and off. So if you hold the control button and press P, then you can see you can show and hide all the additional waypoints. And of course, with this, it looks a lot more complicated than having the route without waypoints. So, and that works for all routes where you have something like a corridor, an area scan. So through this, you can easily change that. And quick side note, in case you want to see more, different keyboard shortcuts, what you can do inside of UgCS, then you can open up this shortcuts window through here, and you can see all the useful things you can do. For example, you can do things such as hide and show the elevation window simply using the P keyboard shortcut. So maybe some of you who are more experienced, users who are already used to using UgCS, maybe this is also something new for you, which you didn't know. I know for sure even some members of our own team, they were surprised when I showed this to them, that actually for this specific thing, there's a shortcut. But yeah, anyways, that's quick side note. And now let's kind of get back into it. So this is, well, essentially how you can plan the basic Circlegrammetry mission. I think all the parameters I kind of went through and explained. So all the parameters you can play around with. For the circle radius, at least initially, I would recommend to set this something like half of the altitude. That's kind of, well, as a rule of thumb. Maybe some of you will disagree. Some of you might want to use a larger value. That's completely fine. That's just something which I was also using initially. So this is the Circlegrammetry tool in essence. And let me just maybe before we move into some data, I'll see if there's some interesting questions. So yeah, there's also, I see there's one question about testing Circlegrammetry against canopies of crops and forests against conventional. That's an interesting application. When we flew over the ex-military polygon, which I'll show you in just a second in the data, there were some trees, but that was not our primary focus. One thing which I did notice is that when we compared standard double grid against the Circlegrammetry, then Circlegrammetry managed to essentially produce better texture on the objects which were within the forested area. And I'll show that to you. Yeah, another question from David is, can Circlegrammetry be used in steep terrain? So I think this I sort of answered. So answer is yes, it can be used in more steep terrain. Well, here it's somewhat flat, but I think I can still maybe try and see if I can move this whole route a bit further to where we have this hill, just so you can see kind of how it looks like. Obviously, this isn't very steep, but just so you can see some terrain changes in here. Well, you can see it, I believe, in the terrain elevation window, that you can still fly these circles even when you have some changes in the terrain elevation. And what's more is that if you go here into the advanced settings, you can see we still have the AGL tolerance parameter. And for those who don't know what this is the parameter which allows you to actually adjust the resolution at which the drone will follow the terrain. So for instance, 3 means that for every 3-meter change in the elevation, the drone will change its altitude by 3 meters. Well, the UgCS will insert a waypoint at that time. So for instance, if you change this to 10, then you should now see that, so the route will change less often. So you now have less waypoints compared to before. And let's see what else. Oh, yeah, another interesting question, yeah, from so for terrain following, if we have already SkyHub and altimeter, could we use that to be more precise? I'm curious to hear for what sensor at low altitude surveys would you like to use this? I mean, you can. So you're not limited in any way in that sense. So if you have already your terrain following kit and you want to fly, for example, 10 or 5 or 2-meter altitude above the ground using the Circlegrammetry tool, you can do that. That's no problem. So you can also, in theory, do terrain following missions with this. Okay, I see some more general UgCS questions. Maybe I will. Let's do this. We can just go through the data that's there, and then we can try to answer some of them. Yeah, and I see there's a question from Christian. So how is it possible to see the GSD? Answer is, for now, in this first iteration of Circlegrammetry, there is no separate GSD indicator. So you can't, unfortunately, see that. But so, as I said, we wanted to push this tool out faster so more pilots can use it. And if we understand, this works, there's people, who really using this, finding new uses for the tool that maybe we haven't even thought of, then of course we can add the just some display of GSD in there as well. So let's see, what else can I answer now before we go any further? Oh yeah, so the point of interest, it's calculated at the center of each circle. So as the drone flies through each circle, the drone is facing the middle of that circle. Yeah, so as it's flying through that, so of course the camera angle, it is set manually. So the camera doesn't adjust to the what's kind of, exactly on the ground. So the camera angle you can play around with, as I showed. And okay, let me see. Okay, and yeah, another question from Andreas. I see. Does this work with PX4 and Autopilot? Answer is yes. So this tool is also compatible with PX4 and Autopilot-based drones. But okay, there's quite a few questions, but maybe let's first go into the data. And so the example that I want to show you guys, and then I can go through all of your questions and try to answer as many of them as I can. So I'll just briefly now switch on over to the laser tag polygon, just so you can see the Circlegrammetry mission, which I flew there, because through Agisoft, it will be a bit more complicated to understand that. So now let's go into open mission, and then we can go just into Sigil the laser tag. This is a town in Latvia, so kind of in the if our office is located in Riga, so then this is kind of more northeastern part, well, the middle of the country, more or less, you could say. So this location itself, it's actually like I mentioned before, it's an old abandoned military base, which has been now converted into a laser tag polygon, where kids and other people can go and play laser tag. There's different interesting objects there on the ground. That one you'll see, of course, here you can't see it in that much detail, just in UgCS, because I have no map overlay imported here. But you'll see that more of that when we go into the processing. But here I just want to show you, this is the Circlegrammetry route that we flew. And also you can see that the flight duration is about 12 minutes here. So yeah, and we can just also go through some of the parameters, and I'll explain how I planned the mission. So we took off from this location that's here. So there's this sort of outdoor terrace where we were based. And so I have one waypoint before the Circlegrammetry, then the Circlegrammetry itself. You can see I used wide camera. I wanted to fly as low as I possibly could in this location. So you can see there's plenty of trees all around. So I set the flight height to 36 meters. The drone's actual flight height was around 38. So usually it does change a bit. And the flight speed is set to 8 meters, also what I mentioned before. And then the radius of these circles is set to 20 meters. Shots per circle were set to automatic, camera angle was at 70 degrees, and circle overlap was set to 50% overlap. So these are all the settings which we used. AGL tolerance set to default, 3 meters. Actually, we did fly also this whole area with 45 degrees for the Circlegrammetry, but the 70 degrees managed to produce way better result. I think it's primarily because of the amount of trees inside of the area, so that when the drone's camera was facing more downwards, because of that, we managed to get better results here. And so in the same area, we also flew with DJI Pilot 2 app. And also the selected area, I try to kind of get it as close as I can. I wish I had screenshots now, but if you go on to our YouTube channel, we'll maybe send the video also in the email later on. You'll also be able to see the DJI Pilot 2 mission. And there, of course, as I mentioned, it does overextend it a bit, which did cause some issues also, which you will see in just a bit. So with that out of the way, let's maybe go here into the results. So I'll just reshare the screen. And let's go into Agisoft. Okay, so now you should be able to see that. I'll just minimize some of these Zoom windows briefly. So this is the result from Pilot 2 mission. And let's now maybe switch here into the, let's maybe do texture model first. And let's just get maybe a bit of an overview of what this area is and what sort of objects are located in here. So that's the sort of parking lot that's there. And here we have our first a bit more interesting object. So this is the labyrinth that's here. And let's maybe try to adjust the camera angle just slightly. So again, Pilot 2, and this is what it managed to produce off the labyrinth. So overall, it looks okay. But as we switch on over into the elevation view, we'll be able to see some somewhat interesting things. So just a second, I'll need to adjust the camera angle slightly here. So here you can see it actually, this is one of the first things I noticed. So the labyrinth walls, in many of these cases, it's somehow merged together. So it doesn't understand that, the labyrinth itself, that the walls should be, simply perpendicular. So this is what the standard Pilot 2 mission managed to get out of this. And now let's maybe compare this against what we got from the 70-degree Circlegrammetry. So let's go here, and also then I'll switch to first to the textured model. And now let's again switch into the elevation view. So here you can see that, well, of course, in some cases, still, you can see that the walls are a bit merged, but in comparison, this is already visibly better. That this kind of geometry, it did manage to capture better, and it struggled less with something like this. This is one of the examples where, at least that I noticed, where we managed to get better results. So now let's maybe go again quickly back into the pilot 2 example. And let's switch on again, maybe over to the textured view. I'll just adjust the camera angle ever so slightly. So over this area, like I mentioned, you see the polygon. Then there's this building, with different tires around where people can run in, and all around there's also some objects here on the ground. So you can see these walls with the tires mounted, and there's other buildings here as well. And then there's this sort of garage area, how I believe it's called, where there's different trucks parked in there. So now as we go in here, for example, for this building, you might notice that there's a bit of a issue with the facade, so with the texture here. So because of how Pilot 2 works, because it flies, what kind of way out and then flies in, then I believe in this case, maybe some trees were in the way or something, but you can see that here there's some issues with the texture on the facade of the building. Similarly, what you'll see is that as we go and take a look at what's here on the ground, then there's a bit of a similar issue. So if we, for example, go in over here, you can see there is some old military truck that's overturned on the side. But here also we can see a similar thing. So we can see that this texture is also overlaid here on the ground. And now, just to compare, we can also go back into the Circlegrammetry. Let me just quickly again switch into the textured view. And so in this case, we managed to get better results. So if we go here and then adjust the cameras, here you can see that the building's facade is without any of those issues which we saw there before. So it's just one of the examples where, at least in this case, it managed to produce better results. And similarly, if we, sorry, the camera control in AgriSoft, for me, it's still a bit complex. So here, yeah, for instance, if you look here on the ground, it's better, of course, here near the trees themselves, because, this is quite a large tree that was over that area and we flew above it. So there's still, of course, some issues over here, but at least in this place on the ground, we managed to get, again, better results. So yeah, those are at least some of the examples from this polygon, and another one would be over here. So this is, let's maybe first, again, I'll show you how it looks like in Pilot 2. By the way, I wish we could have gotten more data sets, because this is just one example. So I'm really curious to see where you use it, because I think there's a lot more where this tool could be useful. So for instance, old castle inspections, railroad inspections, things like that. Factories, there's a lot of different applications for this, I believe. So let's go in here in the textured view, and then let's move the camera around a bit. So about some objects here on the ground, for instance, also what I noticed with some Pilot 2 results is, for example, here you can see there's some door on the truck, and also that it didn't exactly manage to capture the frame of this. You can see there's some part missing over here, and here something a bit similar with that door that's over there. Here you can see also some details on the roof. And now we can also switch. Oh, here also I can see, for instance, there's some door open, and well, here it didn't capture that detail particularly. There wasn't I really love if I could show you also the example of electrical boxes where it did manage to get better result near our office, but yeah, I couldn't really find that. But okay, let's now switch again into the 70-degree Circlegrammetry, and let's go into the textured model that's over here. And so some of these details did manage to produce more accurately. So for instance, you'll see that some of let's look here. Yeah, so some of the doors. So for instance, here you can see, again, the geometry is a bit better. Here, similar. And so all of these tiny details, including, for instance, also things like the car tires and the shape of those round objects on the ground, it does manage to produce more accurately. But I think the best showcase actually could be for the labyrinth, because this, is already sort of more complex structure that's there. And here it does manage to work better. But so like I mentioned, this whole data set, both so Pilot 2 and Circlegrammetry, they were flown at about 36, 38 meter altitude. But so what we also wanted to do when we were there, we wanted to fly at a lower altitude. So we decided, okay, let's try to capture this whole labyrinth at an altitude of about 20 meters. And for that, actually, we managed to only do Circlegrammetry, because for the Pilot 2, we didn't manage to fly this low simply because of the fact that it does overextend these flight lines in both directions. So then for us, there was the risk that the drone would crash either into one of these towers that's here or into the trees that are over there. So yeah, let's maybe just quickly switch on over into UgCS. I'll show you guys the exact flight that we did. And yeah, we're switched in here. So now let's maybe hide this one and I'll show you the labyrinth. So for the labyrinth, you can see the sort of mission which I planned. So there's basically 4 rows of circles. And the flight altitude here is set at 20 meters above the ground. So that's just to give you a bit of an intro initially. And now let's switch on over into Metashape again. So just a moment, and that's here. Okay, so now we are in the Circlegrammetry model of 38 meter altitude. I'll now again just so you maybe have a better way of comparing. So again, let's see how this whole data looks like from the 38 meter altitude. So all the details, you see all the railings here and so on. Let's just move the camera around a bit. And now let's switch on over into the data set which we captured from a 20 meter altitude. So let's go into the labyrinth. So this was only, like you saw before, this was only for the labyrinth section. And now let's go into the first the textured model that's here. So you can, of course, already see it, things such as all the signs and everything. Obviously, as we fly from lower altitude, all of this is captured better. And now we can switch on over into the elevation view here. And so here you can see how well it manages to reproduce this geometry. So for instance, you can see all of these railings, which are here, that manage to understand, the shape of this quite well. And then, of course, also the whole, geometry of this labyrinth. Let's maybe move the camera a bit higher. You can also see there's basically almost no places where the walls are merged. So in this kind of situation where there's some more complex objects on the ground, then you can see what kind of results it manages to get. And also, yeah, by the way, there was a question about how does the vegetation on, sort of the tops of the trees look like. And so here you can see a bit of that in here in this model. And now we can switch on over into textured model and, also just, or maybe let's go actually into the solid model, just so you can see how it looks like from this view as well. So yeah, that's just one of the examples of what sort of data you can get. And really, I think one of the big advantages is the fact that you can do those lower altitude surveys with this tool. And the more complex objects you have to inspect, the better it is that you're able, to fly and capture those objects from multiple different angles and yeah, get these kind of results. But okay, let's now maybe switch on over back into UgCS, and then I'll go through what questions you guys have written so I can see what can I answer. So let me just open this up. Okay, so one question from Clark was, from where does the program obtain terrain altitude data? So for UgCS, by default, we're using the SRTM, 1 arcsecond elevation data. But depending where you are, you can also use your own custom elevation data. There's different public databases available. If you're in the United States, then you can use the USGS service. And in other countries, of course, there's other public data sets. So many pilots also have their own that they are using. So in UgCS, you can very easily import your own terrain elevation data. So I'm just going to try to mark questions which I have already answered, so I can move on to others. Yeah, about how to make sure that the flight paths stay within the boundary. So for Circlegrammetry, the idea is that when you plan it, then the central points of each of the circles, they stay within that boundary. And in case you just want to have it a bit even tighter, then you can sort of try and reduce the size of that boundary. It takes a bit of playing around with to understand how that algorithm exactly works. But once you get used to that, then it's really easy. Another thing is that usually changing things like the direction angle and the radius as well of the circles, then this can manage this as well. So let's see what else I could answer now. Okay, so one question is, from Brandon. So how large of an area can you cover using this method, and that you regularly scan fires of about 1,500 hectares, and how much faster will this be to regular grid methods? So if you compare a regular survey grid, just a single survey grid with Circlegrammetry will take longer. Unless you fly it, with really without any overlap with really big radius. So I think it depends really what's the desired outcome. So for instance, we can maybe go into one of the previous missions that we had here. Let's maybe go into, let's see, was it this one? Yeah. So for instance, if you wanted to plan a Circlegrammetry mission where you could cover a large area, you can do that. I'll just maybe quickly show to you how it would look like. But again, depends on what kind of data you want to gather there exactly. If you want to do oblique photogrammetry, then of course you have to have high overlap between the circles. But if maybe you have some other application where you just want the drone to take some general pictures, fly very, very quickly and capture a large area, maybe this could also be a potential application for that if you're using this for forest fires. So let's just mark out a somewhat large area. It's about 500 by 700 meters large. And now let's actually set, you can see, well, now I have the circle radius set to 25 meters and the flight height set to 50. So we can change the circle radius to maybe some quite large value. We can set something like, let's say 100 meters. And speed, of course, as well. We can set, let's say, 10 meters per second. And so you can see now it's already, the duration is 32 minutes. And circle overlap, maybe in some cases for some application, you would even use 0 if you want to, really quickly scan a large area. And so this is kind of what you would get in this specific case. So you can see the total estimated duration is about 18 minutes, and the drone will be flying just at 10 meters per second, flying all through the circles and taking pictures at angles. So maybe if, let's say in the forest case scenario, it's important to, just cover a very large area as quickly as you can, and, just maybe look at the horizon from different locations, maybe this could also work. That's actually something that's one of the reasons why I wanted to launch this tool, because really there could be some applications for this, I believe, that we haven't even thought about, that you guys as our users will figure out and then come to us and saying, hey, I'm using this in this following way. Can you maybe add this or that? So it's really interesting, I think. So let's see some more questions that we have. Okay, I see. Okay, this one I'll just write the answer live. Okay, can I generate a route like sun path? So this is from Ben Ming Chang. Could you maybe kind of define this a bit differently, because I'm not sure. Do you mean like scanning, like an orb, or what do you mean exactly? Maybe you could explain in a bit more detail. Okay, and that's another from Randall. It's about search and rescue. So 10,000 to 14,000 feet steep terrain, locating lost, injured people. Oh, that's actually also really interesting. This is so yeah, also interesting example. I guess if you need to scan a large area, then instead of flying in the grid, then you can also fly in this following pattern. Just select a very large area, have maybe flight time set to something like, let's say 30 minutes. You can see, for example, this whole area. which is, we should be able to see actually the size of this if we go in here. So yeah, 83 hectares that you would be able to cover in about half an hour if you fly like this. By the way, speaking of the search and rescue case, just one thing I want to show you. If you're using UgCS for search and rescue, we have actually some dedicated search and rescue patterns. So I'll just maybe just very briefly show this so you guys can see in case, maybe you're not flying search and rescue missions by default, but maybe there comes a time when you need to just fly some search and rescue mission. We have some interesting tools here, and I think one of the most interesting ones is this expanding square. So it works in a very simple way. You can set some central point of this. You have some altitude, and the UgCS calculates, this expanding square as the name implies. And here you can change a lot of things. So you can change, for instance, let's say the search radius. So you can, so we set this to 500 meters. You choose what camera you're using. You can choose the drone's flight speed. So for instance, you can set the flight speed to maybe even 15 meters per second. So the drone flies as quickly as possible. So you can cover a lot of terrain very, very quickly. And yeah, you can change the overlap, of course. So that's 30. But actually, what's interesting is even when we compare this against that Circlegrammetry mission, the flight time is somewhat close. Even when here we have about 20 meters. And I believe that there in the Circlegrammetry, we have also, well, obviously do capture more different angles. So that could be one interesting application of this, which we didn't really think about. So let's go again. I'll just open up the Q&A. Let's see what else, what other interesting things have you guys written here. So, oh yeah, so from Richard, the question, how does the software handle cliffs? Are the circles then vertical? So let's maybe go into this a bit. I think I might have to maybe switch, sorry, might have to switch back into this one of the first routes that I did. So let's go back into the Swiss Alps because we have, of course, some more mountains in that region. So let's go here. We can see there's some cliffs, and I can just try to demonstrate how does Circlegrammetry look like if you fly over cliffs like this. So let's then again select the Circlegrammetry tool, and then let's mark out some area. We can even try to, okay, this is quite, very, very steep, but let's see what can we get done with this. So let's just plan some area like so, and then let's see what does the software offer us. And yeah, well, of course, and you can see in this case, the cliff does drop down quite steeply. But yeah, and in this specific case, when you want to scan a cliff that's, almost, horizontal, let's say, oh yeah, almost vertical, then yeah, the Circlegrammetry here, it is not ideal. But actually, we're working on something interesting regarding this, which maybe we could apply for Circlegrammetry as well, but it will be applied to other algorithms. I can't fully yet share what it will be, but I believe that within the next month or so, you guys will find out about what we are cooking. But you can see, for instance, if we move here to some area like so, you can also see how the circles are done. We can change the altitude of them. So let's maybe go up to 100 meters. And so you can actually see that even in this case, when there's quite a mountainous terrain, you can still fly in this sort of pattern. So maybe, for scanning some natural objects, scanning rock faces, this could also be potentially useful. Since we are here, by the way, just one thing I want to show to you is, in case maybe some of you are not aware, I'll just very briefly show the Smart AGL tool that we have in here. I'll just use the standard photogrammetry example because I think maybe some of you guys have not yet, used UgCS, so you could be new to it. And I just want to show what can you do with the Smart AGL. So you can see also we have some cliff face over here. And actually, in fact, we have this totally steep part, and we could even move the route there a bit. But okay, let's see how the route is calculated here initially. All right, I still had the double grid, so I'll just quickly disable that, and maybe just also make things a bit more simple. I could, okay, actually, let's decrease the overlaps just so I can demonstrate the flight pattern itself. So let's make this like so, and the resolution we can change to maybe something like 2. So you can see how this route looks like in this case, and we can also open up the elevation profile in here. But one interesting thing which you can do with the Smart AGL is that, so if you now see that the route, well, it basically keeps a constant vertical distance to exactly the ground below it. That's with the AGL flight mode. But if you change this from AGL into smart AGL, what happens is that UgCS calculates the distance not only to the point exactly below, but it calculates distance to the point that's closest to the drone. So this means that even when you're flying up near a vertical surface, the drone will keep a constant distance to it. But okay, anyways, that's for another webinar. I just want to mention this quickly. Let's go back to Circlegrammetry and the questions that you guys have around it. So then let's go here. Oh yeah, I see another question from Norman. So did you try to use Circlegrammetry data in some other apps like Pix4D, iTwin Modeler, and others? I personally tried using Circlegrammetry with Airsoft Metashape, and I also tried reality capture. In From this dataset, Metashape managed to produce better result compared to reality capture, but I did not yet use Pix4D. Maybe Pix4D also would be able to get quite a good result, maybe even better, because of course processing software also plays a significant part in how these types of images are processed. So actually, yeah, it's interesting suggestion. I might also try to process this same dataset with Pix4D to see what result could I get. Um, oh yeah, really good question, Greg. About the UAV lineup, which are supported for the Circlegrammetry. So currently, even though it's kind of available on all platforms, but which platforms work? So number one, new DJI Enterprise drones are compatible with this. And so this means Mavic 3 Enterprise series, so Mavic 3 Enterprise Thermal Multispectral, then DJI M30 drones, so M30 thermal, and I think there's two versions, right? So the T and N, or the normal one and the thermal one, yeah. M350 and M300. So all these four new DJI drones are fully compatible with Circlegrammetry. And in addition to that, it's also possible to use this on Autopilot and PX4 drones. So these two platforms also are supported. What does not work fully currently are older DJI models. So something like M600, Phantom 4, and Mavic 2 series. These unfortunately do not work yet. But if you guys want to use these drones with Circlegrammetry, let us know. Write to us, please, at support@UgCS, because I believe there is a way how we could make them work. Because since DJI switched between MSDK4 to MSDK5, newer drones have MSDK5 that they are using. It also changes how different waypoints are processed and how different actions work together. For example, on the older drones, you can't have a route that consists of stop and turn and adaptive bank turn points. So it's either one or the other, and certain actions are limited. That's the reason, just so I understand maybe in a bit more detail, why it is not yet supported on older drones. But all the newest DJI Enterprise level drones, these are supported along with Autopilot and PX4. So yeah, can share dataset with a lot of trees obtained with double grid and by Circlegrammetry. We'll see, because maybe we'll actually try to capture a bit better dataset specifically of trees captured using this method, and so then you can see. So you can also write to us at support@UgCS, and then we can talk with you in more detail what sort of example would you like to get. But by the way, one thing I want to mention is that Circlegrammetry, it's available currently on all UgCS licenses. So whether it's Pro license, Expert, Enterprise, so all of these do support this tool. There's no limitations in that sense. Plus, one thing which you guys might not know is that now we have UgCS Pro monthly subscription back on the site. So if you go to ugcs.com and then you go to the Pro license, you will be able to get the UgCS Pro for $99 a month. And okay, let's move forward into the questions. Oh yeah, so from Bennett question, so what drone, what sensors were used to collect this example data? Yeah, sure. So in this case, the data we gathered with over the polygon, this was gathered using Mavic 3 Enterprise drone. So just your standard Mavic 3 Enterprise with its camera, with the wide camera, was what we used to collect this data set. I believe if you used something like, M300 or M350 with the P1 camera or H20, you'd probably get even better results from this. So yeah, also similar question here from Earl. Yeah, so of course, if you would be using a higher resolution sensor and maybe indeed, like you mentioned, combine some LiDAR data together with this data, you could get even better results here. Oh yeah, also another from data processing point of view, another question, yeah, about DJI Terra. That could also be really interesting. So processing this data set in DJI Terra as well, and then we could maybe actually we could probably publish some comparison where we have certain data set processed using standard settings in Metashape, in let's say Pix4D, Reality Capture, DJI Terra, and then kind of putting them up against each other, seeing which one does better with this algorithm. That's an interesting suggestion. Thank you. Yeah, about ground control points. Yeah, they're essentially the workflow is basically the same as linear photogrammetry. Because I mean, let's say when you fly with something like Pilot 2, Oblique, they're essentially it's the same. Also you just set the ground control points, mark them, and then as you do data processing, you just utilize them. Okay, let's see then what else. Yeah, there's another question about the flight time difference between the regular and the Circlegrammetry. So yeah, in general, Circlegrammetry using its kind of standard settings for oblique photogrammetry, it takes a bit longer compared to single grid, but it takes less time compared to double grid missions. But as we saw already before, so if you want to use Circlegrammetry for things such as, let's say scanning quite large areas, the good thing is you can actually adjust a lot. So you can adjust the radius, you can adjust, speed and things like that, and the overlap, and you can actually make it take less time. Because I wish I could have 100 different dates comparisons. That would be really interesting. But one thing I've really noticed is that even from less data, you are able to get either as good or in some cases better 3D geometry compared to those standard grids where you collect quite a lot of data. So that's one kind of direction where also I think we could do a bit more research and testing, and also maybe publish some interesting comparisons. Oh yeah, another question I see. Can I recommend a certain set of settings for the camera angles? So I believe I went through this, but let me maybe see if I can jump to one of the previously planned routes that we had. I believe this maybe was a route to here. Yeah. So yeah, for the camera settings, like I mentioned, so I would probably suggest starting with something like 70 degree angle for the camera. So yeah, 60, 70 degree angle for the camera. The flight height, well, I just did 50 meters, well, in this example, but of course, the lower you go, the higher resolution data you will get. So usually just, try to fly. If you have a, not a very large area, you can try to fly as low as, the area allows you to fly. And then the radius, usually you can set about 2 times less than the flight height. So the flight height and the total diameter of the circle, so they are roughly the same. At least that's what I was using initially, but maybe you'll discover that some other settings work better in your case. Okay, let's see what else is here. Yeah, but Mavic 2 Enterprise Advanced, this I mentioned that, yeah, these older DJI drones, they're not yet supported for Circlegrammetry. But again, let us know, guys, if you want your drone to be supported, if you want it also to be able to use it on Circlegrammetry missions, then the more requests we have, the higher the chance that we will also add this. So yeah, and for the there's one question also about the labyrinth. Wait, let me see, because I think it's kind of a combination of different questions, because some of you guys can write one thing in Q&A and then I have to find where's the other one. So I'm just trying to do that now. Okay, another question from Maxim. What would be the easiest way to add a specific point of interest for a specific structure and plant? So for Circlegrammetry missions, usually you have the point of interest set for every single circle. However, if you wanted to, for instance, fly a Circlegrammetry mission, but have only a single point of interest, so that through all of those circles, you'd be looking towards a single point, that is actually possible. I haven't flown a flight like that myself, but I can just quickly demonstrate. So how would you do something like that? So here you can see I have my Circlegrammetry missions here. I'll maybe actually do, let's do a duplicate of that. And then I will, let me hide the previous one so we can work with this new one. And then we can convert this route into waypoints. So any UgCS route that you have, you can convert into waypoints. And after we do that, you see the route looks a bit like this. Let's hide the previous one. And then on this route, what we can do is we can essentially go here into the actions, and then we can clear all actions. Then once all actions are removed, then you can, for instance, set the point of interest. And let's say, for example, you can set it towards this area that's here. And now this means that through all of the circles the drone will be flying, that the drone will always keep a constant point of interest towards this point. So it's also one interesting case where you could probably use it. And this goes for any mission in UgCS. So for any mission, if it's photogrammetry, area scan, or even just a separate waypoint mission, you can set a point of interest there. So I hope I answered that question. Let me switch on over to the previous route that I had. Yep. Okay, let me also, I'll just mark it's answered. A lot of questions today, I see. Quite a lot of interest for this, seems like. Yeah, can I show how to process data after flying until exporting to the point cloud? Actually, in this case, I didn't do any. I know some of you guys do maybe some raw image processing. In this case, I didn't get that much into that. I just got, the JPEG files. They were already geotagged since they came from DJI Mavic 3 Enterprise. We flew with RTK GPS enabled there, of course. And then simply I put all the pictures in the Agsoft metashape and then just went through the standard process of processing that data. Does this method work for LiDAR surveys? Oh, that's actually also interesting. No, so theoretically, yes, it does work. And I'll show you actually how you could use this for LiDAR. So it depends on what LiDAR you're using. If you're using a DJI LiDAR, so something like L1 or L2, then one thing is you will need to add waypoints before the Circlegrammetry, just to make sure that the LiDAR sensor is turned on and off. I'll just maybe create quickly a new mission. It's interesting. Actually, to be honest, I didn't think that, this could also be used for LiDAR survey. So let's do M300. And now for the M300, let's just add one single waypoint over here. And then in this waypoint, we can add, you can see this action, so LiDAR recording, and let's do start recording. Then we can add just a second waypoint over here, and then here we can do to stop LiDAR recording. Then we can again select the first waypoint, and then sort of in between them, we can add some very simple basic Circlegrammetry mission. We can select the LiDAR that we would be using, but in this case, LiDAR is just used as the camera. So let's mark out this area over here. And yeah, so what will happen in this case is, so now you have one waypoint before, one after, which do LiDAR sensor triggering on and off. And of course, if you have some other LiDAR, maybe something made by Yellowscan or Regal or whatever other LiDAR sensor you have, then usually those work independently. So there you don't need to add those additional points which turn the LiDAR on and off. So there you can simply plan your Circlegrammetry mission, get started. Only thing that there probably for the camera, you might want to have the camera set either downwards, or maybe some of you will set it also at an oblique angle. So here, of course, the overlap you kind of have to control yourself, because in this case, of course, we don't have the LiDAR field of view, but actually what the field of view does for the LiDAR area, let's say. So it simply, adjusts when you fly to adjacent lines, it adjusts what overlap you have between two adjacent lines. But yeah, LiDAR you can actually also use with the Circlegrammetry. So that could be quite interesting. So this also market I answered. Yes, about some flight rules, that's a question from Matteo. This I believe I just answered. In case maybe you feel I didn't answer it fully, just let me know. From Ryan, yeah. So is the Circlegrammetry designed to complement linear and grid flight path missions, or is it intended to completely replace them? I'd say it can be a bit of both, that in some cases, if you want to do oblique mapping, I believe Circlegrammetry can replace to some extent the double grid oblique missions. But at the same time, if you, for instance, use a Circlegrammetry mission and then complement that with the standard grid where you just capture nadir images, I think this could also work quite well. So I'm also really curious to see how you guys could use it together. Maybe there's also some case when, For instance, you can use a Circlegrammetry, fly a mission with very little overlap. So maybe even, this 0% overlap, just capture, multiple different images from oblique angles, and then combine that with sort of this standard mapping grid with the camera pointing nadir. This could also be really interesting, I believe. So, question from Michael, or you're saying that you have been actually supplementing some of your missions with this method manually for a while. So yeah, I'm glad to hear we managed to help you. And yeah, so maybe actually after the webinar, I'll get in touch with you because I'd be also really curious to hear how are you using it currently, and how. Oh yeah, I see. Also, you mentioned about that. Of course, during an overcast day, we could probably get even better results. But that just happened that when we flew those missions, it was this period where basically every day there was sun shining. It was crazy. So I was, hoping that we could get like a cloudy day when we had this field trip planned, but unfortunately everything was sunny. But yeah, now since autumn is here, there would be some cloudy days soon, I hope, so that then we'll also be able to compare both these methods on an overcast day. And yeah, of course, in some cases, yeah, probably, some of these shadows were probably could have caused some issues in the data. So of course, ideally, you would want to capture all of this on a completely cloudy day. But I'm glad to hear that you're happy that we implemented this tool. Okay, let's go further. So, sorry guys, we're a bit over time, but I see a lot of questions and I want to answer as many of them as I can. So from William, there's a question of that you do missing person searches. You need detailed model of the forest and quality 3D models using Circlegrammetry over conventional scans obvious. Okay, let me read it fully. Okay, so is it possible to plan out a route in and around the trees in Metashape and then import that route? I mean, okay, if you want to import a route inside of UgCS, actually you can, I believe, export from Metashape in KML, because that's one of the best ways how you can get something inside of UgCS if you want to import a route. You can import either a CSV or KML. KML is the most commonly used one, I believe. So you can import routes into UgCS from KML files. Another question from Rod. Have you tried it with a GPR? Not yet. But I think the problem is that if you try using this with GPR, I mean, with GPR, it's important that you fully cover different locations from a low altitude. And so, especially it's considering the drone is turning using in the Circlegrammetry missions, I'm not confident that it would work with the GPR. But I mean, if you have one, then, and if you're willing to try, then it could be interesting. Okay, let's see what else. I won't be able to answer all of your questions, unfortunately, because there's a lot. I didn't actually expect that many, but let's see. Yeah, can I go quickly into loading offline maps and flight plans for UgCS? So yeah, for offline maps, you can do this here through the map layers. So just go here into offline maps, or right click anywhere, and then you can just mark out some area, select it, and then click on create, and then a new offline map will be cached. You can actually cache quite large areas, so even 100 square kilometers per a single area. Yeah, from Jesse, another question. So have we tested combining a normal single grid with large radius Circlegrammetry? That's what I was mentioning. Yeah, this could be really interesting to see the results of large radius Circlegrammetry with maybe some small overlaps, then combined with a single grid. That's something actually which we could do, I believe. We just need to find some quite interesting location which to scan, because actually there's a lot of interesting locations here in Riga where we could fly, but many of them are within the city, and then of course have to deal with all the permits and making sure that you can legally fly there, especially if you want to publish that data set. So we have to be very careful and make sure that we are allowed to fly in that specific area where we can collect some interesting data sets. So it's not just, here's our small office. Okay, then let's see what else. Yeah, another question about LiDAR, and this I believe I already answered. Oh, I see from Clark. So you said you tried Pix4D with good results, but DJI Terra managed to process Circlegrammetry data very well. That's interesting. That's interesting. And actually, I might try DJI Terra processing for this data set, seeing what it does with that. Because maybe Terra manages to get better data set than what Agasoft Metashop managed to produce. I see many of you guys are actually already using the Circlegrammetry, and that's really interesting and exciting as well. I'm super curious to hear what you will come up with and what different data sets you will gather. I hope that you can maybe share some of that with us. I'd be really curious to hear. By the way, we have a Facebook group of UgCS users. I believe some of you are probably already there, but in case you're not, then please do join and do share the data that you gather using Circlegrammetry. Question from Christian, I see. Can you set a ground resolution in Circlegrammetry? Again, like I mentioned, it is not yet there, but if we see there's enough demand for that, then we will add the possibility to at least see the ground resolution in Circlegrammetry, or maybe even planning the missions by setting the ground resolution there. That could be really useful, I believe. Okay. I think I'm gonna have to read through some of your questions a bit later after, and then try to maybe reach out personally to you, because I think there's so many interesting cases that you guys are mentioning. And have we tried using this with a magnetometer? I mean, also interesting case, because yeah, I believe there's no magnetic surveys done with Circlegrammetry yet, because initially this was intended for photogrammetric purposes, but I mean, technically, you could also use a magnetometer on a Circlegrammetry mission. There's nothing stopping you from that. So that could also produce maybe some interesting results, because especially you can also play around with the overlap. Yeah, we have I think a few magnetometers in our office, and we might try with one of them, seeing what can we get. Okay, I think I managed to scroll to the very bottom of the questions that were here, and I tried to answer as many of them as I can. And yeah, in case I did not manage to answer your question, please forgive me. There were too many of them. But like I said, firstly, you can always write on our UgCS Facebook group. So just type UgCS users on Facebook, and then you will be able to find it. And you can post your questions there, post your ideas, screenshots, and so on. And I'm also there daily. I'll be able to answer that. And you can also reach out to me directly. Also, I'm on LinkedIn, so you can also just drop me anytime private message on LinkedIn, and I'll be happy to chat with you about different applications. And of course, if you have some more technical questions, you can also ask us through our support email, so support@ugcs.com. So anyways, I think I'm sorry we were a bit over the time limit, but at least for me, it was super, super interesting, because I heard quite a lot of new different applications for our Circlegrammetry that we added, which I didn't even think about before. And I'm genuinely really curious about what you guys will do with this tool now that it's out. And yeah, please let me know what cool data sets you gather. Post them on our Facebook group, post them on LinkedIn. Make sure to tag me in that. And yeah, thank you again so much for joining this webinar. Hope it was as interesting for you as it was for me. And then see you in the next one. Thank you again. Bye-bye.